Hey everyone, welcome back. Today we're diving into an absolute must-know for your exam prep. NCUSI 7.5, 3.2 Uplink bond or load balancing modes. Look, if you're gearing up for this certification, you already know that mastering the networking stack across AOS 7.5 and AHV 11.0 is totally critical to passing. So we're going to break down exactly how these virtual switches handle traffic load balancing and failover, and we'll take it at a steady pace so you can really lock in the mechanics. Here's our roadmap for today. We'll start with why uplink bonds matter, unpack the default active backup mode, explore active-active and MAC pinning, check out a non-homogeneous NIC edge case, expose some common exam traps, and finally wrap up with those key facts you've got to memorize.
All right, let's jump right into Section 1, why uplink bonds matter.
Precision is absolutely everything on this exam, right? So let's quickly lock in our foundational terms. OVS, or Open vSwitch, isn't just software. It's the bedrock routing all your hypervisor traffic. Then there's VS, Virtual Switch, which is the logical piece you actually configure. When we need to bundle physical links for more bandwidth, we use LACP, or Link Aggregation Control Protocol. That forms a LAG, a link aggregation group, on your top-of-rack switch. And of course, MAC and NIC are your media access control addresses and physical network interface controllers. So why do we care about all this? Well, the big takeaway here is that a bond ties physical interfaces on the AHV host into one logical pipeline. Imagine your top-of-rack switch suddenly loses power or a physical NIC just completely fries. With redundant connections, your VMs won't even notice. They'll just keep right on humming. This isn't just a suggestion. Nutanix strictly requires redundant physical connections for a stable cluster. Moving right along to Section 2, Active Backup, the default. Let's look at the baseline limits here. With active backup, the Open vSwitch hashing algorithm pushes all traffic over just one active adapter at a time. This means your maximum throughput is hard capped. In a standard 10 gig setup, you're getting exactly 10 gigs, max, and that's for both the entire host and any individual VM. The backup link? It's literally just hanging out, silently waiting on standby. Now, why is this the recommended default out of the box? Picture this, it's Friday afternoon and you're rack and stacking a brand new Nutanix cluster. You love this mode because it needs absolutely zero complex configuration from your network team. No support tickets, no trunking delays. It's totally seamless. If port 1 on the switch fails, AHV instantly detects it and flips the active traffic to port 2. Boom, instant high availability, zero headaches. Okay, let's hit Section 3, Active-Active and MAC pinning. Check out this massive jump in host throughput when we actually need more bandwidth. We've got two distinct flavors of active-active here. Active-active with MAC pinning, which OVS calls balance-slb, and true active-active using LACP, which is balance-tcp. Both give your host a combined 20 gigs of throughput, but pay super close attention here. Only balance-tcp lets a single VM NIC burst up to that full 20 gigs. Balance-slb permanently pins each VM's MAC address to one physical adapter, meaning any single VM is strictly capped at 10 gigs.
If you take just one thing away from this comparison for your exam, it's the physical switch requirement. Let's say you've got a massive SQL Server VM that literally demands 20 gigs of peak bandwidth for end-of-month reporting. You absolutely have to use balance-tcp, but that means calling your network admin to manually set up LACP and a link aggregation group on the top-of-rack switch for every single node. Don't want to bother the network team? You can definitely use balance-slb instead since it requires zero switch config. But remember, that SQL VM will hit a hard 10 gig ceiling.
So when you select Active-Active in Prism, the system silently applies some very specific defaults behind the scenes. It sets the LACP speed to fast, that's 1 packet per second, so failures are detected almost instantly. It sets the mode to active with a fallback to active backup and priority to default. Here's a huge exam tip for you. You cannot modify these default settings later, not even in the command line interface. Why? Because messing with LACP timers on a live system is a fantastic way to cause a catastrophic network lockout. The system is literally protecting you by locking these down.
Let's jump into Section 4, the Non-homogeneous-NIC LACP edge case. Listen closely to this part because it tests exactly how well you know the architecture constraints. Under normal circumstances, Nutanix is incredibly strict about NIC compatibility. The golden rule? Never mix different vendors, different operating speeds, or even different software drivers in an active bond. If you do, you're asking for unpredictable load balancing and severe packet loss. Exam scenarios love to try and trick you on this.
But there is exactly one exception, and it's when you're dealing with network offload or single-root I/O virtualization features. If you absolutely have to connect non-homogeneous NICs to support these features, your only supported option is active backup mode, and you must explicitly place that odd NIC out, the offload NIC, strictly in the backup position. Why? Because an offload NIC can't process the same complex packet hashing algorithms as your standard NICs. Put them in an active-active bond together, and it's just pure chaos. Drop packets everywhere. Keep the odd hardware on standby.
Okay, Section 5, Common Exam Traps.
We're going to deliberately expose the pitfalls exam writers love to set up for you. First up, never ever fall for a scenario that suggests putting one host in balance-tcp for a heavy VM while leaving the rest of the cluster in active backup to save time. Mixed bond modes across AHV hosts in the exact same cluster are totally unsupported. The whole cluster network stack has got to be uniform.
Now lock these 3 operational behaviors into your brain. Trap 1, re-imaging a cluster will ruthlessly wipe out your beautifully configured active-active policy. VS0 will immediately revert to its factory active backup setting. Trap 2, updating an existing bond is not a seamless, in-place thing. AHV actually tears down the virtual interfaces entirely and rebuilds the bond from scratch, meaning you will definitely see a brief connectivity drop. And Trap 3, never attempt to mess with a virtual switch while a background AOS or AHV upgrade is currently running. Just don't do it.
All right, home stretch. Section 6, key facts to memorize.
20 gigabytes. That's the maximum VM NIC throughput, and you can only achieve that if you are using the active-active balance-tcp mode. Do not let the test trick you into thinking MAC pinning or active backup can magically push 20 gigs to a single VM. It literally can't. Next up, that automated LASCP fallback behavior we talked about, it's absolutely crucial. Think about it. What if there's an LACP negotiation failure with the physical switch? Or you boot a brand new node that just has the lightweight Discovery OS factory image installed on it. This fallback mechanism makes sure the port doesn't just die, it drops gracefully back to active backup, giving you seamless IP connectivity so you aren't completely locked out of a new node. Burn this slide into your memory. You've got to instantly link the Prism name with its OVS terminal name and its limits. Active backup is the default, capping at 10 gigs for both the VM and host. Balance-slb is MAC pinning, needs 0 switch config, and gives 10 gigs to the VM but 20 to the host. And balance-tcp, that's true LACP, requires top-of-rack configuration and pushes the full 20 gigs to both.
I'll leave you with this final thought-provoking scenario. If your perfectly tuned, balanced LACP cluster suddenly drops its max throughput to 10 gigs right after a node re-image, what exactly happened? Well, think about the trap we just covered. Re-imaging tears out your custom LACP config and ruthlessly throws VS0 right back to the default active backup mode. Knowing exactly how this system reacts under the hood is what separates a pass from a fail. Good luck out there on the NCP-MCI 7.5 networking section, and definitely keep actively exploring these configs in your own labs.